The name of the topic is about mining data streams, and the data is infinite information that is gathered from multiple sources, such as sensors, or if it is a website, then it is a search query through which the user is interacting, or if it is a blogging site, then the people are writing the blogs, or if it is a Twitter site, the continuously people are writing or some tweets. So such kind of information is continuously generated, and we want to analyze it, and it's infinite information. Okay, and we want to filter it, or we want to sample it, or we want to fire the query on the streams to get some valuable insight, so that we can take some business decisions about it. Okay, so here what we are going to do is that we are learning about what is meant by a data stream. Okay, in such a kind of it's application, we use the term as a data stream. Wherever there is an infinite information that is getting generated, and if it is a continuous information generated with a rapid speed, so high velocity and high volume, and high variability. If all these three characteristics are there, in that case, we call it as a data stream. The data that is generated is called as a data stream, where the data is continuously generated, it is infinite, it is generated with a very, very high speed. So the speed is such a high that we cannot store the data. And if we don't store the data is lost because the new data will be generated. Okay, so in that case, such data set is referred as a data stream. So the term is a stream of information, continuous stream of information, continuous data that is getting generated. So here the term is data stream. And the chapter name is mining such data streams. Okay, so what are the things that we need to remember about this particular chapter is about what are the real world applications. So first we will realize what are the real world applications where we have to do such kind of mining operations. And then to perform such mining, the standard model that is used is called as the DSMS model. The DSMS means it is a data stream management system. Okay, the short form is DSMS. So it is similar to the RDBMS architecture. So it is a data stream management system architecture for performing mining on a continuous stream of information, infinite information. So what is this architecture? And then what are the issues that we face whenever we are firing the queries, or whenever we are doing the analysis? What are the issues and challenges that are present, that also we need to understand. After that, there are multiple techniques, like it is infinite information, and it may be possible that the entire information is not needed for us. Some of the information is garbage, so we can use a filtering operation. And for that, the topic is called as a Bloom's filter. There are many types of filters which are possible, but as per the syllabus, we are going to learn the working of Bloom's filter and its application. So one of the application of Bloom's filter is while your email inbox, when it receives an email, it has to recognize that whether it is a spam or it is a real email. So in that case, the technique such as Bloom's filter is used. Okay, and also sometimes instead of doing the analysis on the entire stream of information, we take a sample, and on the sample should be taken in such a way that it should be a good sample, so that we get the results which are near to the exact results. So there are many stream sampling techniques are there. So in this particular topic, we study about the sampling techniques. And then in such a huge information of continuous information that is getting generated, for that there are two types of algorithms which are there as per the syllabus, that is counting distinct elements in a stream. Counting distinct elements. So if it is a stream of information, you count the unique elements in a stream. That is the Flageolet-Martin algorithm. So for that, we are going to learn Flageolet-Martin algorithm for such a kind of data stream, and the working of that, and how to solve any problem to find out the distinct elements. The application of counting distinct elements is identifying unique users logging into the particular website. Okay, like Amazon, they want to find out that how many unique users have logged in the last month. So for such kind of query, the operation is counting distinct elements in a stream. And the algorithm that we are going to study in this chapter is the Flageolet-Martin algorithm. Then there can be another algorithm. There's another algorithm called as DGIM algorithm, that is Datar, Gionis, Endike, Motwani algorithm. These four people, they work together, and they came up with the algorithm called as DGIM. This algorithm is for counting number of ones in a window. Like here, we sometimes we can use a concept of a sliding window where we can keep the information in the form of zeros and ones, and we want to find out how many number of ones are there in the window at a particular time. Okay, so overall, this particular chapter is about continuous stream of information, and we want to analyze such kind of information. What are the real world applications of such kind of data streams? And what is the architecture for doing such analysis? Is that architecture is called as a data stream management system called as DSMS. So the block diagram of DSMS and the working of DSMS, and such a huge information, what are the issues and challenges that are there, then how to overcome them, and that we need to understand. And then sometimes we use the filtering techniques and sampling techniques to overcome the challenges and to get some approximate answers. For that, we need to understand about the sampling techniques. There are three sampling techniques as per the syllabus: reservoir sampling technique, biased reservoir sampling technique, and concise sampling technique. And then for filtering, there are multiple filters possible, but we are going to study about Bloom's filter. That whenever the continuous stream of information is the input to your system, then filter unwanted information and consider only the information or data sets which is of your use, and filter and discard the data elements as and when they are created, discard them. Use only or filter them and use only whatever is relevant to your application. Okay, so this is overall the idea about this particular topic of mining data streams. Now, we know that whenever we do the data mining, data warehousing and mining kind of operations in the traditional database system, we already have the data, and the data is stored into the relational database management system such as Oracle or SQL Server. And this data is a persistent information. This is a persistent information which is available permanent. We just get the information, we do some pre-processing on that, we remove the stop words or some other unwanted information, and you convert your data into a particular format, and it is stored in the relational database management system, and it is residing there. Okay, so it is a permanent information, it is a persistent database which is already there, and it is residing into your machine in the traditional database warehousing and mining kind of operations. And then as and when we require, we perform the mining operations and algorithms on this data warehouse or the persistent database, and we get the results that are useful for taking any strategic decision by the higher level authority in the organization. So business organizations, they want to get some insights as per their requirements, and they can fire the queries on such a persistent relational database, which is integrated from multiple sources, and it is available permanently into your database system. Okay, and then we do it. So it is very easy because it is already, entire data set is already available. You have the data set, and then on the available data set, you are firing the query. But there are many data mining situations where we don't know entire data set in advance. Okay, we don't know exactly how much data elements are there. We don't know the entire data set. Data set is always incomplete because it is continuously generated. So it is called as a real-time transient data stream. Such kind of data stream, I think all of you know the term stream that we use in Java also when we studied Java. The data input data stream, output data stream. Stream is a continuous flow of information. Stream is called as a continuous flow of information. Okay, so I don't have to explain you about the stream. I assume that you know already what is meant by a stream. Stream is a continuous flow of information. That is that can be the input information or that can be the output information, depending on the input data stream or output data stream. Okay, so we in real world there are many data mining situations where we don't know exactly what is the entire data set, because the data is continuously generated and it is a real-time data. Means at that particular moment, that particular value of a particular sensor or particular variable is there. It is generated at the real time, and as it is generated, it is getting lost, and because the new data is getting generated. So it is a transient data stream. It is not permanently stored somewhere, because it is continuously generated, and if we don't do anything about it, then it is getting lost. Okay, so in case of mining data streams, your data is real-time data and it is a transient data stream. It is not permanent or persistently stored in the database, because it is infinite. If it is infinite data, then we need to, if we want to store it, you need a huge memory, like infinite memory, and the data is generated with such a high speed that there is no time to store the data and then to fire the query on that. As soon as it is generated, it is getting lost because the new data is immediately getting generated. Okay. Just imagine the scenario where there is a sensor, and the sensor, millions of sensors which are placed in the area like ocean, and we want to find out the temperature, surface temperature, or we want to find out some other parameter by using the sensor, like the high the temperature around the surface. And then these such millions of sensors are generating this information for the particular time, and that they are sending to the centralized controller. Okay, so in that case, we may want to generate the alert whenever the maximum temperature is achieved, or if the temperature is greater than 25 or 50 with some condition, we want to generate the alarm, or we want to generate the alert. Okay, so in that case, such kind of mining is useful. But the sensors are, if there are millions of sensors and if they are creating the temperature values at every second, then it is a huge amount of data, and it is generated with such a high speed that we cannot store it and pre-process it, and then we perform the analysis. Because it is a real-time information, and real-time action is to be taken if the temperature is greater than, if the current value is greater than some threshold. Okay, so imagine such situations where we have to deal with the situation, and we want to perform something which is useful for the business organization. Okay, so here also one of the important concept is that the stream management is important. Such kind of stream management is very important when the data input rate is controlled externally. Means here the data generation is not controlled by the organization. The organization is getting the input from the data which is generated by some external entity, and the input rate is not controlled by the organization. It is controlled by external entity. For example, from Google's point of view, the queries that are getting fired is not in the hand of Google. Google has just created this website, and the queries at every second, the number of queries that are getting fired is not in the hand of Google. So here the data is a huge data, huge number of queries are getting generated at a particular second. And what they do is that for a particular query, they may store the information in the form of a tuple of your row of your relational database management system. Like they may want to store the information such as who is the user who has fired the query, or from which IP address the query is fired, and what is the query, what is the time of the query that is fired, because they may want to use this information in future to recommend the user with some products depending on his queries which are fired by him. Or they may want to analyze that what are the different types of queries which are fired in a particular day, or in a particular previous 1 hour of time, what are the types of queries which are fired by overall public in the at a particular area. And depending on that topic, they may want to provide you the results in an efficient manner. Okay, so they may be analyzing the queries which are getting fired in the last 1 hour. Okay, in a particular area, like in Mumbai, in last 1 hour, what are the different queries which are fired by different users, and they want to analyze that, and they want to quickly provide the improved results, so that they have to take the action in the real time, and they want to provide the results quickly, and a good results. Okay, or they may want to analyze the user, like what are the different queries which are fired by this particular user in the last 15 days, and depending on the queries which are fired by the user, they may want to recommend him with some advertisements or with some products. Okay, so here such kind of information or such kind of operations they may want to perform. Or if it is a Twitter or Facebook, then the status updates is not in the hand of Twitter or Facebook. It is status updates is done by the client or the people who are using their websites. So number of status updates are very high, and they may want to analyze that because they want to improve their performance, or they may want to use that information with some business organizations. Okay, and so we have to always think that in case of such a kind of mining data streams, your data is infinite. The data is infinite, and it is not non-stationary. Okay, it is non-stationary. Distribution changes over the time. Okay, now always for the stream model, as I said, you stream means a continuous flow of information. In the stream model, your data arrival is so rapid that it is, if it is not processed or stored immediately, it is lost forever. Okay, so remember this information. Like data arrival is very it is at a very high speed, and it's a huge data by multiple sources, and it is, if it is not processed immediately or if it is not stored immediately, then it is lost. Data is getting lost if we don't do anything about the data. Okay, assume a sensor creating the data about a particular variable. So a sensor may have multiple variables, and it is setting the values of multiple variables, and there are multiple sensors, and in a millisecond they are just sensing the information. And if that information is not processed, or if it is not stored immediately, then it is lost. Okay, so that is the issue here. Like data arrival is very it's so rapid that if it is not processed or if it is not stored immediately, then it is lost. Okay, now even the second thing is that the algorithms that we are going to use to process such kind of data, it has to do such a processing under strict constraints of space and time, because your data is unbounded. Data is unbounded, unlimited information. So algorithm will also become unbounded, but but we have to perform or process this data in the constraints of space and time. Okay, we cannot take an infinite amount of time to fire the query and get the answer. So these are the issues. So you think in that format. Like now you need to change your thinking from your normal data analytics to this real-time analytics. Here there is a real-time data. The data is infinite. It is getting continuously generated with a high speed, high velocity. It is entering in your system with a rapid rate on one or more input ports. Because there can be more than many ports are acting as an input port to your system, and data is arriving across these multiple ports into your system. So it's a huge amount of information entering to the system at a rapid rate. Okay, and we may consider these elements, or refer these elements of the stream as a stream tuple. Okay, like you see this diagram here. In this diagram, this is your system. This is your system, and this is your input stream. Input stream, it is 152,709. So it is a decimal information, or it is all the characters entering into the system, or all number of zeros and ones entering into system. And these are the multiple streams. Multiple streams, or continuous stream of information acting as an input to your system. And here, this is the element of the stream. Okay, and this element may not be a single bit. This element can be a maybe a tuple. Okay, the element can be itself a tuple. Okay, like here I'm saying these streams are entering, and each stream is composed of elements or tuples. So here the streams are entering to your system, continuous stream of information, at a rapid rate, and which is not in the control of the system. This data generation is not in the control of the system, and it's a huge amount of data and infinite data, and it is continuously generated. It is not going to stop. And so the data arrives in the form of an input element or a stream element, and the stream element, it is called as a tuple. It can be also called as a tuple. Okay, so that's what I'm trying to say you here, is that your data is entering at a rapid speed at one or more input ports. So multiple streams may be entering to your system, and the element of a particular stream is called as a tuple. And the tuple, for example, for a Google's website, this can be the tuple, typical tuple, but it may be having multiple, more than one parameters. So it is similar to the row of your database system, relational database system, where one particular record may contain the user ID, the query fired by the user, and the time at which it is fired, the location of the user, then the language in which it is fired. All such things can be the part of the stream tuple. So it is not a single element; it is a group of information. Okay, so that is called. So have you understood the stream tuple? The stream tuple is the stream element, and such a multiple stream elements are getting generated at each and every milliseconds or microseconds, and we have to capture this information. If we don't capture it, if we don't process it, it will get lost, or if we don't store it, it will get lost. We have to do something about it. We have to either process or store it somewhere for the temporary amount of time, because it is not possible to store all this information in the secondary storage device, because it is infinite information. So whatever the secondary storage device you are using, it is not going to it is going to get full in some days or some months of time. After that, what will you do? So we cannot store this information, 100% information in the secondary storage device. Okay, but we can store it temporarily in the form of a buffer, in the form of a window, sliding window, and then we can perform some operation on that data which is temporarily stored or captured at some location for some amount of time. Okay. So I think I have just giving you the background about such kind of mining algorithms, like huge amount of information. We have to process it or we have to store it, otherwise it will get lost. Even the algorithms will also have to work in the constraints of space and time, and such a challenging task is there. Okay, so the system cannot store the entire stream, because it is also a fact that the system cannot store the entire stream. Everything cannot be stored inside the system in the secondary storage device. We can store it in the memory for some amount of time, and then because it's infinite information, so it is not feasible to store the information on the secondary storage device. We may summarize the information, we may keep only a small part of the information, so we will have to do something about it. But we cannot store the entire data as it is onto the secondary storage device because of its infinite nature. Okay, and then the question is, how do you make critical calculations about the stream using limited amount of secondary memory or primary memory? So you have to make the critical calculations on such a stream of information. So how will you make these calculations? Using a limited amount of memory. Your memory is primary memory or secondary memory is a very limited amount of memory compared to the huge amount of data. And how will you make the critical calculations about the stream? Uh, because it cannot fit into the memory. You don't The entire data set is not visible in front of you. Only partial data is visible in front of you, and the data can be categorized into three parts, like history data, current data, or the future data. And the future data will become your current data, and then it will become a past data, and the past data is now lost. The current data, which is temporarily available inside the buffer, is only visible in front of you. Okay, so let's see what are the different types of mining operations that you can perform on such kind of information. And depending on this also, you can take a particular topic for your mini project. So what we have to, what such kind of applications do is that For such kind of applications, we have to identify and define a set of query types that DSMS should support. Okay, like suppose it is a Google's website, and they want to perform the mining on the query streams. Then the job of analyst is to identify and define a set of query types that DSMS should support. DSMS is a data stream management system. The database management system, it has to identify what are the types of queries that DSMS supports. So there are multiple types of queries like a continuous queries or ad hoc queries or one-time query. And depending on the type of the query and whatever the information you want to extract, so analysts have to identify and it has to define the set of query and how it is to be executed by DSMS, where to store the query, how to form the query. There is a language called a CQL, which can be used, continuous query language, or in that language you can write down the query. Okay, so analyst has to identify and define the set of query types also. And here the application can be these are the multiple applications. Like Google wants to know what are the queries that are frequently fired today than yesterday. Okay, compared to yesterday, what are the most frequently fired queries on the website? Or Yahoo wants to know that what are the pages they got unusual number of hits in the past hour. So they need to know what are the normal number of clicks on a particular page. Okay, so it can be not only Yahoo, but any particular website which is very popular or any business organization which is having a website which is popular, which is clicked every seconds, like Amazon or some other website where they just want to know. They are doing the clickstream analysis. Each and every click is stored, and they want to analyze it. So they want to know like what are the pages which have got unusual hits in the past hour. Why they want to do that? Because suppose for a particular page, if there are continuous hits are there, then maybe in on that particular page there is some information which is a trending news, or it is also possible that this is a broken link in the website, because on the website there are multiple links and they cannot keep track of each and every link manually. So if there is sudden increase in a particular link, like user is continuously refreshing the page, then that hyperlink is broken. Like this, they can analyze it and they can find out is there any problem in that particular page, or or if the contents are a sensitive content on that page, and that are something has happened and people are trying to see that particular page. Okay, so many people are continuously watching or continuously browsing on that particular page. So in that case also it is a huge information, and it is in the form of a string. Or Twitter or Facebook, they want to find out what are the trending topics, and they want to display them. Or if the satellite information or the satellites which are capturing the images and sending this information uh, to the like the center at a data center, or the telephone call records where the call records are the telephone calls are also recorded, and in the recording, suppose it is used by the government for some security purposes, they want to find out any particular threat, they can identify from the conversation, they can keep track of some people, if there is any sensitive conversation going on which is not which is something harmful to the country or some organization. So they are keeping track of all the telephone records, or even the telephone records are also kept because they have to create the customer bill at the end of the month. So the call duration from to kind of information is stored. Or if it is a call between Airtel and Vodafone, then the settlement between the telephone companies is to be done with this telephone call records, and it is a huge amount of information. Okay, so always we have to remember is that the data arrival is at very high speed. If it is not processed, if it is not processed, stored immediately, it is going to be lost. It will get lost, and algorithms have the constraints to work with the in the constraints of space and time. And the data arrival is continuous. Multiple streams can enter into the system with rapid speed, time varying. Sometimes burst data is there, so you get at a peak time you may get many data items generated, or at some amount of time at night very less data is getting generated. It is unpredictable, and it is unbounded stream, means it is infinite. There is no boundary that the stream is going to end like that. It is a continuous data or infinite data. And the individual data item may be a relational tuple. Individual data item entering into your system is a relational database management system ka record or the row. Okay, for example, it can be the information such as user ID, this firing query, and or like here in the web applications for web page visits, it is a user ID, IP address, time spent on the particular page. Then from URL, he has reached from a particular URL to your URL, and after this URL, he has visited to the other URL. Okay, so so this kind of information is captured at a particular millisecond about the page visit. So web applications may capture the web page visits by multiple users and for a particular user for a particular time, and this is everything is in the form of a timestamp. All these things, all this tuple or information is with respect to with the timestamp. So with the timestamp for that particular time, this user ID logged in is uska IP address ये था. This was the time spent on this particular page by the user. He came from this particular URL. After that, went to this particular URL, and such kind of information is captured in the form of a relational table or a record or a row of a table. If we compare this with the RDBMS, then it is like a row of the table. And then by such information, they may try to find out broken links, or they may want to recommend the users. Okay, so these are many applications, like financial applications also huge amount of information about the stock prices, to take the decision about buying or selling of the prices, to um, recommend, if it is an application, then it may recommend a particular stock to buy or sell, or to predict the behavior of the stock. Then in the network monitoring kind of applications, at the routers, at the switches, or at the firewall server, network monitoring is done where multiple network measurement parameters are there in a particular row or particular tuple. And why they want to continuously monitor such kind of parameters? Because they want to predict, or they want to take the corrective measure action before any attack on the router or on the web server. Okay, so they want to detect any intrusion detection, or they want to prevent any attack, or they want to prevent the failure of your machine. Okay, so the network monitoring also, the data is in the form of a string, or for security purposes also, or security applications also, when the packets are moving through uh, through the firewalls kind of server, whether it is incoming packet or outgoing packet from or to, or the time of the packet, then whether it is a spam, or real packet, or it should be blocked. All such kind of decisions can be taken if this such kind of data is properly monitored by the system. Or in the telecommunication management and data management, it is a call duration, from person to person, time of the call, recorded audio, and such kind of information is used to generate the bill, or to capture some sensitive information by the government. Okay, or the manufacturing companies also, everything is automated, or if it is a computer aided CAD CAM kind of application, then we want to identify or analyze the parameters that are continuously generated by multiple parts of your machines, and we can prevent the defect in the manufacturing, so we can save the money uh, if we can prevent the defect or identify and take the corrective measures. Or if there are multiple sensor networks or IoT kind of networks, all the sensors are reading from multiple parameters, we want to generate the alert or alarm. at a particular situation. Okay, or we want to there are sometimes feedback calls, and calls are recorded by the call centers, and they want to analyze such a recorded audio conversation. Or for the email applications, they want to identify spam email and the real email, or the trending topics, which I have already told you. Okay, so these are the multiple applications. Again, we are going to see in detail some of the applications as per the textbook. Such kind of information, it is not feasible to store in the traditional data RDBMS. Even traditional RDBMS does not support the storage of infinite amount of data. So it is not feasible to store all such information in the traditional RDBMS, and because it will be a rapid generation of the data and continuous loading of the data. So it is not feasible. And the queries also, continuous queries are not once the query is fired and then we are just sitting idle. It's not like that here. Such kind of in such kind of analysis, the queries are continuously fired on the data, on the stream of information. So the query is fired for the particular time, then again after some time gap, again the query is fired. It means the continuous queries, and they are generating the continuous stream of information as an output, or output can also be the output stream. Okay, so and algorithms have to make use of limited resources, time and memory, say, and they must deal with this data. The nature of the data and distribution of the data is also changing over the time. Okay, so because it is unpredictable, so such kind of scenario it is. For sensor networks, we may assume that many sensors are there in a particular home automation system of IoT kind of a scenario where constantly monitoring many parameters. The sensors are continuously monitoring many parameters, and they want to generate the alerts and alarms in response to the information received from a series of sensors. Even imagine a situation where there are multiple sensors, and two, three sensors, they are generating the readings on different parameters, and then we may have to aggregate all the parameters. So some processing is also needed. Aggregation of all these parameters or joins all these parameters over these multiple streams corresponding to multiple sensors. So we may have to perform the joins or aggregation or some operation on the all the readings combined together, and on that basis we may have to get the resulting parameter and identify or predict the situation to generate the alarms or warnings. For example, for the temperature sensors or ocean current stream sensors, the readings may allow us to provide the warning for the disasters like cyclone and tsunami. So such information is changing rapidly even on the basis of the vagaries of the nature. Okay, or if it is a power consumption in the power station, they are monitoring the power usage statistics, and if at a particular location suddenly if there is increase in the power usage, then the alarm is generated and they are get alerted, and they can go through and check what is exactly happening, and they may save something from some disaster, or they can manage the power distribution efficiently. Okay, so they can group them by location, user type, and they can manage the power distribution efficiently. Okay, so these are the examples about the sensors used at multiple places. Or they can be a network traffic analysis as a big application of data stream analysis, where IP packets are monitored at a switch, and the information that they can provide is that what is internet traffic, which are the heavily used routes, and based on this information, router may take a decision about the optimal routing. They can identify or predict the potential congestion in the route, and they can detect the potential fraudulent activities also. Even for as an intrusion detection system, a particular server on the network may become victim of the denial of service attack. Even the route may get congested in a short amount of time. Okay, so all such by monitoring all the traffic, and by observing it, and by setting or designing your system, DSMS system properly, we can get some information and we can save or save the situation. Okay. Or to identify denial of service attack, they may check whether the current stream of actions over a time window are similar to the previously identified intrusion on the network. Like the network administrator, if suppose there is any previously identified intrusion attack, denial of service attack is happened, then they may have that particular data, and in the current situation, in the current time window, if same kind of actions are happening, then they get alerted and they can observe the things what is exactly happening, and they can identify the denial of service attack and they can take the corrective action on that. Okay. Or if the several routes over which the traffic is moving has several common intermediate nodes, then there is a possibility of having congestion in the route that can also be identified at the router levels. Okay, so it is also an example of a huge data stream generation information. In the financial applications, as I spoke to you, it is online analysis of stock prices to make the decisions about holding of the particular share or selling decisions. They can be taken by identifying correlations and fast and changing trends uh, currently happening, and they can do some forecasting operations on that. They can be the queries which can be fired on such kind of data is the query like find all the stocks which are priced in between some range which is showing very large buying in the last 1 hour based on some bank news about the tax cut for a particular industry. Okay, suddenly there is a news in the new media about some tax cut about a particular industry, and and we want to, depending on that news, we want to find out all the stocks which are in between a particular range, which are having the large buying trend. Okay, or find out the stocks trading above their 100-day moving average. A particular stock ka 100-day moving average, but if it is getting more than that 10% with the volume exceeding million shares, so in that case like fire the query like this. So it is a very complicated query, like from RDBMS point of view, if we are going to fire the query, that query will be nested and some outer joins, and it will be a complicated query which will take long amount of time to execute, and plus the data should be there in the RDBMS to fire the query. But for such kind of financial application, data is huge amount of data. It may not be there. Okay, and you may want to fire the query like this. Okay, then transaction log analysis is also one of the major application of data stream, where there is online mining of the example is online mining of the web usage logs. It is with respect to the web applications or telephone call records, which I told you, or ATM machine transactions are also the example of data streams, since they continuously output data and it is infinite data. And the goal is to find out the interesting customer behavior pattern. They want to analyze the customer, and or even they want to analyze some suspicious behavior of the customer to find or which indicates some fraud. Okay, and the queries can be this queries kind of such queries like examine the current buying pattern of the user at a website and plan the advertising recommendation or advertising campaign, or continuously monitor the location average spending of a particular customer, and like credit card companies may monitor the location from where the customer is doing the transaction, or credit card transaction, or his average spending pattern, and they may want to identify the potential frauds in that case. Okay, so these are the major applications. Look, like I can revise them. Financial applications, network monitoring, security at server levels, telecommunication systems, web applications, manufacturing organizations, sensoring networks wherever sensors are used, telephone call records, then email, blogging, Twitter, then financial applications and ATM kind of transactions, all such cases, continuous stream of information is getting generated, and then we have to analyze or do some action on that. Okay. So these are now for such kind of information which is rapid, high velocity, high volume information. What kind of architecture can be there? So it is a DSMS architecture. It is called as a DSMS architecture, data stream management system architecture. Okay, so here these are the components. Okay, as only 10 minutes are left, we will see this architecture in detail in tomorrow's lecture. But I'll just quickly introduce you with the components of this architecture, because it's not possible to complete the architecture in the 10 minutes. Okay, in this architecture, what are the parameters, or what are the elements of this architecture? Components of this architecture. The first component is the infinite stream, which is shown here. And here, remember that it is a real time. It is a real time data. It is a continuous data, infinite data, ordered sequence of events, items. Some ordered sequence is there with the timestamp. Each and every element is a tuple, and along with the timestamp. So these streams are entering. This is the time which is increasing at this direction to the left hand side. So this is the old data, and this is the most recent information generated, and it may be captured here in the form of a window, sliding window, or in the buffer. Some amount of data is captured here for some amount of time, and when the new data is generated, the old data from the buffer is deleted. Okay, so we may have some buffer memory here, and like this is a limited working storage. So in this limited working storage is one of the component. This limited working storage, it can be a memory or it can be the hard disk. So it is a limited working storage, and some storage is allocated to store this generated data. So that data is residing here, which is the current data, that we can call it as a current data. When the new data is generated, the new data item will enter into the stream, or into the sliding window, and the old data is removed. So sliding window should be refreshed again and again. So we may have a buffer where the current data is stored, and if the new data is arrived, then the data from the sliding window is deleted. Some data is deleted, and it becomes the past data, and the future data is also there. So we can categorize the data into three parts: past data, current data, and future data. And these are this one of the component is the stream, which is a continuous stream, real-time data, ordered sequence of items, and the item can be, or element can be, a tuple which may have multiple elements, and it is along with the timestamp. Okay, so this is the major component. Then we may have a query processor component. This query processor is similar to the RDBMS, data processing component. And here the queries which it can process, they are of two types of queries. From There are multiple types of categorizations of the query. So one particular categorization is ad hoc query and standing query, or one-time query. So standing queries are the continuous queries, or long-running queries, or persistent queries. These queries reside into the memory. This query is residing to the limited storage memory. It means they can be in the memory of the system, or they can be in the hard disk. But they are continuously running queries. They are standing queries. They are continuously looking at the current data in the sliding window, and they have also done something about the past data. Okay, so what they may have done about the past data is that they have already seen the past data, so they may keep the summary of this past data, or they may keep the metadata about this data into the secondary storage, in the limited working storage. So what is happening here is that in the query processor, the standing queries are permanently residing here. They are persistent queries, and they are continuously looking at the data which is going through this window and buffer, and so they know about the past data also. And about the past data, when they are seeing the current data, they update the metadata information, or they create the new summary. So summary is also continuously getting generated, and summary will give you the summary about the entire stream of which is processed already. Okay, as and when the new stream is arrived, again the standing queries are looking at this particular data, and they may generate the output. Even they may update the summary information, or they may update the metadata information. Okay, so in this architecture, there are two types of queries: standing queries or ad hoc queries. And ad hoc queries or one-time queries, they are stored in the query repository. Ad hoc queries are fired as and when there is a requirement by the analyst. So analyst may suddenly decide that he wants to get some particular information. So uh, he may fire the ad hoc query, or they can be one-time query, which is fired only once on this entire stream. Okay, so in this architecture, we have at least two different types of queries: standing queries and ad hoc queries. And what is the difference? Standing queries are permanently residing into the system, DSMS system, and they are continuously looking at the current data. They have already seen the past data. They may have generated the output. Output may be a continuous stream of information. Like input stream is the output, like this output is also a continuous output, or it may be it may be it may not be the continuous output, but it may be the output stored into into the device, and it may generate the alert or alarm kind of output. Okay, so there are two types of queries: standing queries and ad hoc queries. And ad hoc queries are fired at any moment, any time, whenever the analyst find out the need about that result. Or there can be a one-time query which is fired on the entire data only once. The storage is of two types: archival storage or limited working storage. The archival storage is for the purpose of archiving the input stream. This input stream can be archived into the archival storage. Okay, it may be possible that the input stream is archived into the archival storage, but it is not possible to fire the query from the archival storage. Okay, so overall these are the parameters, and I think the time is getting over. We'll see what is the time. Okay, so we'll see this architecture now. Tomorrow I'll directly start with the architecture. Okay, and we will learn about DSMS architecture. Okay, so I'll stop for the today's lecture. Have a nice day.